Okay, I apologize for the delay. So let's begin with these examples. I don't know if you've taken a look at them. Hopefully you have tried these. Have you tried them yet? Remember, the goal is to eventually be able to add fractions, so we need a like denominator. So we want to think, what is it we need on both of these fractions in order to get these to be the same denominator? Can you think with me about what the LCD is? We need an x and an x minus 2 and a 6, right? So our LCD, it needs to be 6 times x minus 2. Is that okay? We turn this denominator into that. Hopefully, if we pick the right LCD, then we should be able to multiply something by top and bottom to get this LCD. So what would that be? We'd need to multiply the top and bottom by... Can we get this denominator somehow? We just need an x, right? 7x over 6x, x minus 2. So I'm multiplying the top and the bottom by x. And again, we don't want to have... It's not true that we want anything to have changed, right? So this x, these x's should cancel out, right? And we should still have what we started with. I don't want to have changed the problem at all. It's still the same problem. Over here, if we want to make this denominator look this way, then this needs to be multiplied by x minus 2. Is that clear? And again, this fraction is still the same fraction that we started with up above. Do you agree? It's still x plus 3 over 6x. But now, in this particular form, now we can add these fractions. I'm going to hold off just for a second, though, because I want to actually multiply this out up top and see what we have. So 7x over 6x times x minus 2 minus x squared plus x minus 6, if you FOIL that out. Okay. And now we need to be careful with applying the negative, right? We're doing minus all of this stuff, right? So up on top, we'll have 7x minus x squared minus x plus 6 all over our LCD. And then if we combine like terms, what do we have? Negative x squared plus 6x plus 6, right? All over 6x times x minus 2. I know just by glancing that the numerator doesn't factor, but maybe you want to spend some time looking at that and verifying that, in fact, that doesn't factor, and there's nothing more you could do to simplify that. I promise you that that's true on this particular one. Okay, the second one I hopefully didn't run into too much trouble on. This is similar, at least the setup, the first part of the problem for sure is similar to stuff we've been doing. Is it clear what each denominator needs? It is clear. Maybe if you write it this way, right? If you factor. All right, so what does the denominator on the right need? The one on the left doesn't need anything, but we need to multiply the one on the right by x plus 3 over x plus 3. And again, we haven't changed the problem at all. It's still the same problem. Right, this is still 4 over x minus 3. And now we can add these. So this should just kind of be a review a little bit, right? 6x plus 1 plus 4x plus 12 all over our LCD. So that's 10x plus 13 over x squared minus 9. All right, so that second one is not very instructive. The first one, I think, is of the variety that's still a little bit harder for you, right? The second one is just one more example of stuff we've been doing. Okay, but any questions, especially on the first one? Is this coming together for you? Is this a process you think you can do? We want to see if we can turn our attention to something else too today in this section. Let me know if you have any questions on this. I have a few more examples on here. I don't know how many we need to do though. I don't want to do them all necessarily, but whatever you think is necessary for your own benefit will go as far as you need to go. Any questions about what you see here? And I apologize, in in my disorganization at the beginning of the period, we didn't take a look at the homework, but I'd be glad to. We should take a look at that too. Don't write these down quite yet. I don't see the benefit in necessarily doing either of those unless you want another practice one. You tell me. I think you're going to skip those. Are any of these interesting to me? None of those interest me really. Unless I guess I said, especially the first one is kind of boring. The other two are somewhat interesting. We could do those if you want, but what looks interesting to you? I don't know. Let's do 33. I don't know, just for the sake of practice. I think that this one might. I don't have anything more to say about it. I just think it's the kind of problem that you guys might get tricked up on. So let's all try that right now. I'll give you a moment to do that. That's the one I'm going to recommend. I think the others are okay. But this one, you might get kind of caught on. I don't know. We'll see. Running into any trouble? Give ourselves a little room here. What's LCD? X. Well, we need this guy, and we need this. We need kind of both denominators, don't we? So the LCD is x minus 10, 3x plus 2, right? So if that's, maybe I should give you another crack at this problem here, right? If you haven't figured that out, then maybe you should try again now. Keep going. Right? Can you make both fractions have that as the denominator? What would you have to do to both fractions, right? Think that through. If you haven't already. The other example? So what does the first fraction need? You need to multiply it by what? Is it clear that we need 3x plus 2 over 3x plus 2? So that we get, it'll be 2 minus 5x times 3x plus 2 on top over x minus 10 times 3x plus 2 on the bottom. Okay. Again, we don't want to have the first fraction. We still want the first fraction to be 2 minus 5x over x minus 10. That's all it is, right? I'm just canceling that out. And then what about the second fraction? What do we have to multiply that one by? Jocelyn, how about? X what? X plus 10? Yeah, x minus 10, right? So we get x minus 10 and 3x plus 2 over here as well. Okay? This 3x plus 2 is still here from up above, but we've multiplied by x minus 10 over x minus 10. And if you were to cancel out the x minus 10s, we would still have 1 over 3x plus 2. I just want to keep emphasizing that. Like, we haven't changed the problem at all. But now, we have a common denominator, don't we? So we can add. Before we add, though, let's simplify this numerator. We can FOIL this out. What do we get? 6x minus 15x squared plus 4 minus 10x. And then actually maybe we should add just now, plus x minus 10. So we have negative 15x squared. 6 minus 10 is negative 4 plus 1 is 3x. Negative 3x minus 6. Is that okay if you combine all the like terms? And I just want to think a little bit about the top and whether it could be factored at all. I think maybe not, but let's try. Let's see if we could pull out a 3. Let's do that at least and see what we see. I might pull out a negative 3 just for fun. 5x squared plus x plus 2. And when we think about that, it's a little bit more. Let's see, 10. Yeah, I don't think we can do anything else really though. I mean, if we can cancel anything else out, we would want to do that, but I think we're done. In fact, if you want to stop right here, that would be fine too. Okay, so the reason I highlight this one is because it's another one where we need to do something to both fractions. And second of all, that I think it's a problem in which you might, if you aren't careful, you might get lost in the algebra. Okay, it's easy to miss multiplying this out, right? Or forget to combine like terms in the right way, or I don't know. So my question is, did you do that? Do you understand conceptually, but also can you actually land successfully without crashing on the runway on this problem? Is that okay? I mean, you tell me, are there any mechanical issues, any conceptual issues? You tell me. You understand the big idea at least? Okay, I mean this is hard. That's why I keep kind of giving a lot of pause here. This is not an easy idea. There's a lot of algebra that I'm already assuming that you're strong on. Okay, let's skip those for now, just in the interest of time. Here's the one I'd like to do right now, and I'm going to show you 2 ways to do the following problem. Okay. So the other thing that we'd like to be able to do in this section is to simplify some complex fractions. Okay. So here's the first one I'm going to look at with you. And here's the way that I might recommend that you simplify this complex fraction. This is still the same complex fraction, okay? So if you didn't copy it down, there it is again. I'd like to just work on the bottom right now, okay? And actually, the top too, right? If there needs to be any addition that needs to happen on the top, then we should do it. But this is already one fraction. If we can combine these fractions, that would be awesome, okay? So let's worry about this one thing in the circle first, and we're gonna do this little problem right here. So forget about the big problem. Let's just see if we can add those two together. We need to find a common denominator. That's a different problem, I guess. Okay, we'll do this one by hand here. So how do you add these together? Let's see. What do each of them need? Well, the LCD is x times x plus 2, right? Yeah, so the LCD this is like as if we're adding, 1/5 plus 2/3 or something like that. What would the LCD be for these? There's nothing in common at all, so it's just the product of those two things, right? Like here, the LCD is 15, isn't it? Yeah. Do you agree? Yeah. Okay. Do you agree with that? Well, here, we don't have anything in common at all, right? So we'll just use the product of these two things. X times x plus 2, right? So I want to get both denominators to look like that. So I'm just talking about this one little problem here. And actually here, we'll just do it right underneath here because there's space. It's not a big problem. So I say that this is, if we multiply this by x over x, we get x over x plus 2, x times x plus 2. And if we multiply the second guy by x plus 2 over x plus 2, we get that. And again, at every stage, we should kind of stop and say, hey, is this still the same problem? Is this still 1 over x plus 2? And is this still 2 over x? Okay. So this is x over x times x plus 2. And this is 2x plus 4 over x times x plus 2. And we can add those now together. What do we get? 3x plus 4 over x times x plus 2. Brilliant. Okay. All right, so far so good? So what are we saying? What did we just do? Let's take a step back. What we said is this big fraction we started with, this big nasty thing. Look at the big picture now. We could replace the entire denominator with this, right? Aren't they the same thing? Aren't they the same thing? And actually, let me write that again here. So we said that 2 over x plus 2 divided by 3x plus 4. This is still the same problem, right? Isn't this the problem we now have? Let me go back to the slide just to show you, right? This is the problem we originally started with, 2 over x plus 2, all over this nasty stuff. But we just discovered that that's equal to the thing I've circled down here. You just did this. You just did the work. Okay, so this is the new problem, 2 over x plus 2. That's still the exact same as we started with. Beautiful, wonderful. The bottom, though, I've replaced with our new, better form of that. Do you like it? All right, now let's look at the following pieces of work here, because this is not bad. Once we get it to here, we've done all the hard work. By this thing in parentheses up top, divided by this thing, couldn't we also write it this way, linearly, going side to side? Couldn't we say this divided by this? Because I think you're a little intimidated by the way it's written here, all stacked up. But this, over here, is a problem that we did in the previous section, right? Do you know how to resolve this situation where you have a divided by? Yeah, you do. You multiply by the reciprocal instead and cancel stuff out, right? Like that's a situation. This is maybe a little bit scary at first over here, but this is a situation you're comfortable with. The x plus 2's cancel out, and we're just left with on top a 2x, and on the bottom a 3x plus 4. So in the original equation that we had, it was 2 over x plus 2 over, I'm going to forget now, 1 over and 2 over. 1 over x plus 2 plus 2 over x, right? What we're saying is this original big, big, nasty fraction can be reduced to just that fraction right there, okay? And did you catch the steps? It's a little bit of a long process, so I want to make sure we got the play-by-play. What do? We add the fractions up top. We add the fractions down in the bottom. Now, there wasn't anything to do up top, but sometimes, like what if we had this on top and bottom? We had something crazy. Do the work in the numerator, do the work in the denominator, and we had some work to do. And then multiply by the reciprocal, just like we've known how to do before. Okay? So let's do another one here. And I want to show you another technique for doing these too. I want to show you 2 different ways. I actually don't like the way I'm teaching you right now, but we'll go through it because it makes sense based on what we've just been doing. So again, I want to treat this big fraction bar, the big fraction bar in between these 2 things, as being, for right now at least, an impenetrable wall that separates 2 different, completely different problems. okay? Let's work on the numerator as one problem. And by the way, how do we add those two things? 1 plus 3 over x. Let's do that right now. Let's do that top problem. I'm just going to ignore the denominator for right now, okay? So the numerator, I say that 1, remember 1 is 1 over 1. You could think about it too. So what's the common denominator up here? Between 1 and x. X, right? So I'm going to multiply this guy by x over x so that I can add these. So in the numerator, again, right now there is no denominator, right? Just forget about the denominator. What do we get when we add the numerator though? We get x plus 3 over x. Do you agree? All right, good. Now I want to do the same process downstairs, okay? I want to add these two fractions together. What's the LCD down here? Forget the numerator for a while. We're just working on the denominator. This is a 2 over 1. Can we get both of these to have an x squared in the denominator? I think we can. We rewrite this as 2x squared over x squared. Do you agree that I haven't changed the problem at all? This is still a 2, isn't it? 2 times x squared over x squared. That's still a 2. But now we can actually add these together. We get 2x squared minus 5 over x squared. All right, and actually I guess I don't need this last fraction bar. That went a little quicker than I thought it would. Okay, so do you see the situation we're now in? We've got this numerator divided by this denominator. Let's just pause and breathe for a second. Is that okay with everyone? Does that make sense? And right now, like I said, I've treated this big fraction bar like an impenetrable wall. It's just like, we haven't done anything to cross the divide. I've just basically done 2 math problems separately, haven't I? But now let's stop and think about what we really have. We have something divided by, and that's how I want you to think of a fraction bar always, for the rest of your life, right? That's what we mean by a fraction bar. This thing divided by this thing. Do you agree? If you agree, then you know that we have another way of writing this, don't we? Isn't it equivalent to say this thing divided by this thing and write it this way? Isn't that the same thing? In fact, I don't know that you need to write that if you understand what's going on. And this is an expression that I know you know how to resolve, right? We flip this guy. And then we cancel anything out if there's anything that can be canceled out. So we get just an x up top here. The x squared and the x cancel out, leaving just an x up top. So we get x times x plus 3 over 2x squared minus 5. All right, so that's not terrible, right? We've done it all on one slide this time. So here's the original problem. Let's just make sure we understand what we just did and stare at it for a second. Here's the original problem. And we've said that that equals, when we reduce it, down to this, right? And that's the goal, is to take a complex fraction like this that has a fraction within a fraction and get it down to just one fraction. That would be our goal, right? We don't want to see multiple fraction bars if we can help it. I think you'd agree with that. So that's what we've done. We've simplified the numerator, the denominator, and we've got it down to this. So the strategy right now that I've shown you is to simplify the numerator, simplify the denominator, and then apply the reciprocal, right? Is that okay? There is another way to, I hesitate. Should I show you another way I like to do it? I don't know.
Yes.
All right. Let me show you down here, because I think especially on this problem, you're going to really like this. Okay, so here's a second way to do it, and I want to show you how to maybe do this too. Okay, so here, the other way to do it is instead of finding the LCD just on the top, and the LCD on top was x. And instead of just finding the LCD on the bottom, which was x squared, let's find the LCD of everything all at once. And the LCD for everything on this problem is x squared. Do you agree? Like x squared, the 1 divides into x squared, x divides into x squared, and x squared also divides into x squared. And then I'm going to take this whole fraction, and let's see if we get the same answer here. And instead of doing what I just did, I'm going to multiply the whole fraction by x squared over x squared. This little guy might seem really innocuous, but he's powerful. Are you ready? You see what's about to happen? What's x squared times this numerator? I'm going to multiply x squared by this numerator and x squared by this denominator. So here we go. Can you multiply for me? What is x squared times each of these things? X squared times 1 is x squared times 1 is x squared. X squared times 3 over x is 3x squared over x, or just one of those cancels out, right? So it'll just be 3x, won't it? Isn't x squared times 3 over x 3x? And then the denominator, if we multiply by x squared, what's 2 times x squared? 2x squared. And what's negative 5x squared times x squared? It's just plain old negative 5, and we're done. Okay? Could we have done that on the last problem too? Because this is the same answer, isn't it, that we got there? Could we have done that up here too? Yeah, I think we could have, right? I know the bell might ring here in a minute, but let me just try it off to the side here. Could I have gotten the same answer we ended with on this one? On this one, I would have had to multiply by x and x plus 2. And if I do that, I get up on top, the x plus 2's cancel out, and I get a 2x. And on the bottom, over here, if I multiply this by this, I get x. And if I multiply this by this, I get 2 times x plus 2. Which is, this will be a 2x plus 4, so it'll be a 3x plus 4. Which is, in fact, the same answer we got on this problem, right? So this technique is maybe faster. Like, I kind of like this technique better if you know what you're doing. This is a lot quicker, boom, boom. Like really kind of 2 steps and I was done here on this first problem. So I've just done 2 problems in 2 different ways to show you that both ways work. And this is how you might simplify complex fractions. Your homework tonight, I'm giving you, I have one kind of like thought question that's not very major, but then really just 3 of these to do. So just, you'll see, it's not, even though it looks like more problems, you'll see on the front of your packet. It's really not very many problems at all, okay? And the reason is because they're a little bit intense, okay? So I want you to take them seriously and I want you to actually try them. And maybe tomorrow we can go over both homeworks, if that's okay with you, okay?
Do you have your
Yeah, I see. You see all your classes. Tomorrow's a regular day.
Is it?
Mm-hmm.
I thought that was the HSA. Are we ever going to use any of this stuff?
But there's no HSA.